After finish the sampling method, now we'll go to the calculation part. Sampling error. If we want to calculate the difference between the sample statistic and population parameter, we can calculate the difference by call sampling error. For example, the sample mean minus the population mean, sample standard deviation minus the population standard deviation, and so on. The sampling distribution of the sample mean is a probability distribution consisting of all possible sample means of a given sample size selected from a population. The sampling distribution of the sample means summarize the probability of the sampling error, which is sample mean minus the population mean. The mean of the distribution of sample means will be exactly equal to the population mean if we are able to select all possible samples of the same size from a given population. The standard error of the mean will be standard deviation divide the square root of sample size. N is sample size. There will be less dispersion in the sampling distribution of the sample mean than in the population. As the sample size increases, the standard error of the mean will be decreased. Okay, let's go to the example. Now we have 7 production employees and the hours earning of each employee are given and summarized in the table. A. What is the population mean? To calculate the population mean, we can use mean equal to summation x divide n, which is 7 plus 7 plus 8 plus 8 plus 7 plus 8 plus 9 divide 7. Then we will get 7.71. Then next, this one 7.71. Next, what is the population standard deviation? Population standard deviation, we can use this formula, square root of summation x minus mean square divide n. So we will get standard deviation equal to 7 minus 7.7 square plus 7 minus 7.7 square plus 8 minus the mean 7.7 square plus 8 minus 7.71 square plus 7 minus 7.71 square plus 8 minus 7.71 square plus 9 minus 7.71 square divide n is 7. And then square root will get 0.7. Next, what is the sampling distribution of the sample mean for sample size 2? So which means that from this 7 employee, now I want to choose 2. So by using the combination formula, 7 combination 2 will get 21, which means that there are 21 possible outcomes. This one. This is the sample mean for all possible sample of 2 employees. For example, Joe with Sam, Joe with Sue, Joe with Bob, Joe with Jen, and so on. Then, if this is sampling distribution, if the question asks, report the sampling distribution of the sample mean, we have to report like this. And how we calculate this sample mean is, Joe, we know that the hour earning is $7. Sam, 7. So 7 plus 7 divide 2, we get 7. Then after that, how we get this number of mean 3 is, how many $7 appear? So 1 time, 2 time, 3. Then no. So number 3. $7.50. 1, 2, 3, 4, 5, 6. 7, 8, 9. So 9 and so on. If the question asks you to calculate the probability, 3 divide 21, we get 0.1429. 9 divide 21, we get 0.4285, etc. If we add out this probability, we will get 1 because the probability is from 0 to 1. Okay. Now, since the question asking, what is the mean of the sampling distribution? So how we calculate this? Mean for the sampling distribution equal to sum of all sample mean divide the total number of sample. So 7 plus 7 $5.50 plus this one. 7 plus $7.50 plus $7.50 plus $7 plus $7.50 until the last one $8.50. Divide 21. Then we get 7.71. If the question asks you what is the population for, what is the standard deviation for sampling distribution? So that is the standard deviation, divide the square root of n. Then we get 0.49. And last question is, what observation can be made about the population and sampling distribution? So we can summarize the result by using descriptive statistics, which means that we sketch the graph or we can conclude. For example, this observation can be made. The mean of the distribution is 7.71. The spread in the distribution of the sample mean is less than the spread in the population value. As the size of the sample is increased, the spread of the distribution in the sample mean becomes smaller, which is 0.49. Why I say become smaller is, if you notice, the first time that we calculate the population standard deviation is 0.7. Then after we do the sample mean for that, we are able to get 0.49. So this is the meaning. As the sample size increase, because from 7 we increase to 21, then the standard deviation will be decreased. And the shape of the sampling distribution of the sample mean and the shape of the frequency distribution are different. The distribution of the sample mean tends to approximate the normal distribution when we increase the sample size. Okay. Next, we will go to the center limit theorem. Center limit theorem is if all samples of a particular size are selected from any population, the sampling distribution of the sample mean is approximately a normal distribution. And this approximation improves with larger sample, which means that when n increase, the sample size increase, n increase, then we will get a normal distribution. So if the population follow a normal probability distribution, then for any sample size, the sampling distribution of the sample mean will be normal. If the population distribution is symmetric but not normal, the normal shape of the distribution of the sample mean merge the sample as small as 10. If a distribution is skewed, for example, positive or negative skew, that we have learned in topic 4, if I'm not mistaken, then it may require samples of 30 or more than 30. The mean of the sampling distribution is equal to population mean, and the variance is equal to variance divide n, and the standard deviation is equal to standard population standard deviation divide square root of n if approach normal. this is how we summarize and display in the graph form. If the sample size is 2, 6, and 30, we can notice that increasing the sample size, we can get a normal distribution. Okay, for these two examples, I just skip it. Okay. Then the next video will discuss using the sampling distribution of the sample mean.